All right, I think, yep, we are recording, and let's get started. So, someone mentioned, and this was a great idea in last week's feedback form, and yes, we read those, is we just need to, revise and revisit the stuff that we did previously so that everyone's on the same page again this time around, and that totally makes sense. So, just going to share this notebook with you guys, this Google Colab file. And I'm going to set it to view only. So remember, like last time, just make a copy of it in your local drive. And that should, that's going to be the version that you're going to modify. You're going to edit your own copy of it. So there's a link in the chat to this notebook, and it should be view only. And the instructions are up here, but once again, just for consumability, we'll go through it. So once you open it up, you go to File, go to Save a Copy in Drive. And that's going to open up a copy of BankChurners Part 2. It's going to be up here in the top left. You can rename that if you want, but it's going to be local to your personal drive. No one else is going to be able to modify it at the same time. And that's, that's the idea. And remember, this is a hosted runtime on Google servers. So we are going to, I need to share this with Sammy real quick, 1 second. All right. Sorry about that. The music is loud. Let me try to turn that down. Is that better? All right, cool. All right, so once you have it in your personal drives, then connect to Google's runtime, because we are not running this on our local system. Google is very kind, and we're going to run this whole thing on their servers. Yeah, just gonna wait for like 15 seconds until everyone's done. So I'm going to send the link again. The link that I sent in the chat right above is what is, I can send it again. Okay. I think we can, what?
How did you save the program?
So it's saved as a file in your Google Drive.
Okay. All right. Yeah. Because you were saying something like after we opened it, we were supposed to do something. Like I missed that part.
Oh, you just click on there's a connect button at the top right. So you just connect to Google's runtime. And this is all hosted on Google servers. So we're going to be executing the code on those Google servers. Just hit that connect button.
Okay. All right. I did it. Thanks.
I think we can get started. So first thing we want to do, oh yeah, go to Kaggle. If you don't have a Kaggle account already, just go to Kaggle, make an account. It's super quick. Just sign in with Google or something and download the data set. Download it to your local system, from which we're going to be uploading it into this Colab file. So that should take about 30 seconds. Yeah, it's the same data set as last time. If you have it from last time, it's totally cool. I'm just saying it in case there's people in here who might not have been here last week, just running through it in the next 10 minutes or so, just to recap. Okay, so assuming you've made your Kaggle accounts and downloaded the data set, run that first cell here, and that's gonna open up this little choose files button. Click it. Locate your file. It should be saved as, it should come in a zip file from which you can extract the actual CSV, and it's going to be called BankChurners. That's what we're going to be uploading into Colab. Okay.
So, wait,
yeah.
Is there like anywhere in particular we should extract it to, or?
You can save it wherever you want in your local computer. That as long as you can access it again to upload it into this Colab notebook. So once you run this first cell, you hit choose files, and then you can select wherever you save the BankChurners.csv file. The Kaggle link, I can send that. Okay. If anyone wants me to slow down or go back, let me know, and we can do that. All right, so our standard stuff: pandas, numpy, seaborn, matplotlib. We're going to run that cell to import these libraries that do so many wonderful things for us. We're going to create a data frame that reads in the CSV. This is all stuff that we implemented last week, so just going to execute everything and walk through it. So the data came in, and it's in all sorts of formats. There's some missing values, like that one over there, just as unknown. And we need to get rid of those, and we can afford to get rid of those because it's such a large data set. We're going to find out the size and the shape of it. Yeah, there were some extra columns at the end that we didn't want to use for logistic regression. This is a statistical model. It's a naive Bayes classifier. We're not really getting into that, even though it's pretty cool. But yeah, so this next cell is going to drop out those last two columns. And then we move down to renaming the attrition flag column as label, because that's our target variable. That's what we're trying to get the model to figure out by the end, right? Our goal is to predict whether the customer will leave, given all this information about them. Then we're gonna just find out some quick stats, an overview of each of the features. We're not really gonna go too deep into the analysis because this will involve statistical knowledge. But if you're curious, you can explore that. It's really cool. We're gonna check the data types of each of the features, and as you can see, most of them are integers, some are floats. That's fine. We want numbers by the end of this whole process before we can feed it into the model. And these object data types are strings, and that's a no bueno. We need to convert everything into numbers. So we're going to create a copy of that data set just so we can modularize the changes to a copy, like a checkpoint. Let's look at our copy, make sure it actually works. And now, first thing we want to do is get rid of the values that have unknown, get rid of the rows that have at least one unknown in them. And the way we're going to do that is this little for loop that basically says this data set is now going to be equal to this data set minus all the unknowns. And that's what that little not equals is going to basically do. It's going to iterate through all the columns and check if any value in that column is an unknown. It's going to chuck that row. That's basically what that does. And yep, as you can see, we had row number 3 had unknown, and now it's gone because we have 0, 1, 2, 4, 5, and we can keep moving. We can check the new shape. I'm sorry, there's something in my eye. All right, yeah. We're going to check the shape, and we've lost a few thousand columns, like 3,000 columns, rows, not columns. We lost 3,000 rows because we deleted the unknown values. That happens, and in a large data set, it's okay. Otherwise, we would try to cheat the data somehow. For instance, if we knew where the data was from, or if we knew how the data was collected, then we might want to do something like filling in the unknown values with the average of people of that, I don't know, demographic, that region, or whatever else, that environment. And that might be one way to do it. Another would be to randomize and reassign that unknown value. That's like a whole null value treatment step. But for simplicity, we're going to be just deleting anything that has unknown in it. Are we good so far? Am I going too fast? Is it all good? All good? All right. If anyone needs me to repeat anything, just feel free. Yeah, so we're going to be just covering everything till what we did last week, and then Sammy's going to take over for feature engineering, which is the new thing that we're going to be implementing today, and then running the model. So last time we did this thing where, still uploading the file. Okay. Do you want to just hang on until
It's
that's done?
fine. It's fine.
Okay.
I'll catch up. Yeah.
All right.
Thanks.
Cool. And then we need to encode the actual non-numerical values into numerical types. And you can see in some columns there's high school, there's graduate, marital status, married, single. It's all over the place. It's just different kinds of data, and the model can only process numbers. So we need to find a way to standardize that. There's multiple ways to do it. Like we said last time, a common one would be one-hot encoding. But this manual version of converting each category into a number, like assigning 1 to high school, 2 to undergraduate, 3 to graduate, so on, that's a way to convert that into numbers. So we're gonna run this. Now what this process does, and this is something we implemented last time, where we just assigned each value a number in each of the respective non-numerical columns. And what this tends to do is it implicitly places some sort of order on the data. That's a reason that we don't like to use this. If we want to use one-hot encoding instead, that's a perfectly valid reason, because sometimes data doesn't have an implicit order. Gender could be female, male, it could be male, female. Just because time is linear, we have to pick one way to do it. But if we were doing one-hot encoding, doesn't matter what what order we place them in, because those vectors are orthogonal. If you don't understand what I said, that's okay. Don't worry about it. So we're gonna encode each category and then replace the non-numerical values in our data frame with the now numerical values. And let's take a look. Everything that used to be a word is now a number. Education level is now 1, 2, 3, so on. The card category, it used to be blue, silver, gold. It's now numbers as well. Where is the card category? There it is. All right, all these blue customers. Let's look at the data types just to make sure that we've done everything correctly. Yep, everything seems to be either an int or a float. That's what we need. We need numbers. Yeah, so with that ends the preliminary data cleaning phase. And now we can actually draw up some plots. This is only like a small taste of what the actual process looks like. And if anyone here is in the 320 class, you probably know what went down yesterday, but it's the actual process of data cleaning and data exploration is absolutely intensive. You'll have to perform like a much wider variety of statistical analysis. What went down yesterday in 320, it was the project was a little bigger than expected. So the people who were trying to hang on till this week to get started on it paid a price for it. I may or may not have been one of them, but I think we got it done. Most of us managed to get it done well in time. But yeah, no, it was a totally useful project. We had to scrape some data from a couple of websites and then convert everything into a data frame and then do some manipulations on that. So it was really useful, like in building that skill. Yeah, it's not as breezy as I thought, but it's definitely fun, to me at least. Okay, so the first plot here is going to check the balance of the data set. How many people have actually left versus stayed in the data set? And that is an implicit bias in the data towards the people who have stayed, because that's just how the problem is in the real world. If banks had more people leaving than staying, there's a systematic problem there. So we're trying to figure out from the smaller proportion of the people who have left, how likely someone is to leave, and what, like, if you want to go into explainability, that's a whole other topic, what drove them to leave. So once the model makes the prediction, you can actually go back and analyze the factors that led to the attrition. But we're not getting into that as of now, but it's really fun to talk about explainability as well. And then we can do this really quick correlation heat map that compares two variables and lets us know how positively or negatively these variables are correlated. And yes, they says after what we do here, you'll have a good background and knowledge to approach that class. Yep, definitely. This is kind of like a primer into the folks interested in getting deeper into machine learning, AI, deep learning, and data science. So this is kind of just giving everyone a taste of what it is, and it's helping us learn along the way too. We are very much your peers, so we're just sharing what we've done so far. So yeah, from the heat map, there's some observations we can make. One is the client number is something that we don't really need in the data set because it's not going to influence whether someone leaves or not. It's information that the customer generally doesn't have. And it's just not consequential enough to keep. So we're gonna want to drop that out. There's a high correlation between total transaction amount and total transaction count. Let's find this transaction amount and transaction count right there, the 0.81s. It's a very high correlation. Can we do something with that? So the goal of feature engineering, which is the next step, is to try to convert our data into something more useful and sort of refine what goes into the model. So this is something that we want to look into. And then finally, months on book and customer age have a high correlation, but they might both indicate attrition tendency. So we're going to be looking at a plot of that as well very shortly. Remember, Seaborn is the library that we're using to draw up these plots. Matplotlib kind of helps us modify those in our usage of it. You can draw these entirely up in Matplotlib, that's also fine. But Seaborn has this really nice visual to it, so visual element to it. So the distribution of the customer's age seems to be, like what you would expect, normal distribution around the mid 40 to 50 range. So that's okay. And there doesn't seem to be a massive skew, right? If the distribution leans one way or another, that's called a skew. And there doesn't seem to be anything like that in the actual people who left. It seems to be somewhat normal, like a bell curve, like even around the middle. So that means it's not a huge difference and we don't need to worry about age much, but it just gives us a nicer understanding of the data. Let's look at a box plot, which is, oh, okay, there we go. It froze. Yeah, so a box plot is another way to look at the data, and this basically shows the median, the 25th and 75th percentiles, and then the range, and then these little dots are the outliers. This is all stats stuff, but it's again another way to understand the distribution, the spread of the data. So that's we're just showing you the features. This isn't the full process. Right, so this is an important graph because look at it. It's spiking up right in the middle. It just says 36 months, everyone is like on that one value. That probably says something about how the bank collects the information from the people. They might be like, and there might be some policy where they need to collect these details when the customer's been with them for 3 years. And that also indicates that, more people have left because like, that's when you're actually getting in a lot of your data. So, but if you look at the relative difference between these two bar graph thingies overlaid on one another, it's pretty much the same. So it's not like the number of months on book is necessarily affecting whether they'll leave, because the proportion is somewhat similar. But we do need to know that the data has been biased towards this 36-month value. So we might want to take care of that. We don't want the model to train on extremely biased data. That's never a good idea. Again, box plot for the same thing. You can do other fancier distributions from it. All right, the next one, we're gonna check how many relationships or products with the bank that customer has. And this one actually points out something to us. If you look at the actual distribution of the people who stayed versus left, those who stayed have more products with the bank than those who left. You know, that kind of makes sense, because if you're willing to stay, you're gonna want to buy stuff and become like a more loyal customer, and then the bank might reward you with some sort of extended credit deadline or higher credit amount, and that's like the relationship that builds up between the customer and the bank over time. But the people who left don't really have much of that. Yep. And there's the box plot that definitively shows people who left have less. Oh no, this is a sorry. This is for revolving balance. People who left have less balance on their credit than the people who stayed, and that also makes sense. Like I said, the bank might give sort of rewards to loyalty as a customer. Here's a link. There's more visualizations in here. You can see like a more thorough picture of what features are like actually affecting the label as a human. Analysis is for the human to understand and test a hypothesis, come to some sort of conclusion, but machine learning is for us to predict the future. The human can understand the past, and that's what we're good at. We're good at analyzing the past, but we're not necessarily the best fortune tellers, but machine learning is changing that. So that's why we move to machine learning. Anything up to this point before Sammy moves on to getting all of you guys to implement these steps? Okay, I think that's a good sign. Sammy, do you want to take over?
Yes, sir.
Do you want to share your screen with this thing?
Mm-hmm.
Okay.
Sure. Okay. You disabled screen sharing for me.
All right, there we go.
All right. And just to keep it lean. I have a weird recommendation page. Don't just ignore it. Now I have to share my audio as well. New thing. Share sound. Is volume okay?
You might want to turn it slightly down, very slightly.
Okay. It's good. Perfection. All right. Oops, that's not a thing. So, right, as Rohit was saying, we're now going to take a look into feature engineering to see how we can change certain things about our data to make it better for our model so that we can ultimately get a better accuracy rate at the end. So, we're just reading off here, now that we've standardized the data and we've explored the data a bit, seen some relationships. There's 3 things that we can do in this very brief dive into feature engineering. Now, if you look at the data set, right, and if you look at client num, that seems to be the most irrelevant column to the problem, because if you think about it, it's like if you were trying to find a correlation between your, university ID, if like a student, if we're looking at students, and if we're looking at a correlation between your ID number and the chances between them leaving, there's nothing there, right? It doesn't make sense to include it. So we can drop that column entirely. But before that, like we did a couple of meetings ago, when we make major changes to our data set, we can make a copy of it and store it in the new variable, right? So I'll give you 30 seconds. Why don't you do that right now, and then I'll code it up for you.
After those 30 seconds, if someone wants to, just type out their answer in the chat, that's also cool.
Mm-hmm. Also, Rohit, if you could keep track of time, that'd be great.
Okay. I didn't look at the clock at the start, so I'm keeping track of the measures in the music.
That's one way to do it.
All right. Annie has the answer. Good stuff.
Yeah, exactly right. In fact, to prove that it's right, that's pretty much exactly what we have to do. Just cut. Just run it anyway.
You're gonna have to run all.
That is annoying. Oof.
Rishi, this is in the new BankChurners Part 2 file. This isn't the same file from last week. It's added on, like we have this whole part of it added on. I'll send you the link.
Give me a second. I have to. Can't believe I didn't download this beforehand. Okay, there we go. Now take this. Sorry for the technical issues, guys. I'll be back in a second. Okay, cool. Put this here. Okay, now we can finally upload it. Choose files. There we go. Okay, I'm going to share my screen again. Appreciate you for standing by. Okay, so now that that's done, we can move on to this one, import all the libraries. Then do this. Then we do this. And then we do this. And then we do this. Yeah, I don't know, dude. This is really repetitive. Then we do this. And then we do this.
Just hit run all, and it's gonna fail at the point that isn't implemented.
Oh, true. That's also true. But like, I feel like I'm already committed to this. I've got to finish what I've started. Okay. The music does help with awkward silence, though. I will admit that. So how's your week been, guys? We had 2 CS midterms, the whole BigTh team, which is really intense. As long as our first 351 midterm, that was pretty. I don't know what to say about that.
I just realized we're like halfway in already. Are we really? You guys took your midterms?
Yeah, I guess so. Time goes by quickly. Anyways, yes, finally, we've reached here. And yeah, just like Annie said in the chat like 10 minutes ago, approximately, that's how you make a copy. Now, as I was saying beforehand, we want to get rid of the client num column. So I'll give you another 30 seconds or so, and you can code up the solution to drop the client num. And remember to use your, whatever you named your new copy of the data frame. All right, wrapping up, going once, going twice. All right, does anyone want to shout it out or put it in chat? So I mean, yeah, that's the general procedure. How do we do it specifically for the column? Yeah, right on the money. And take this and do this. Let's see if that works. And then for good measure, of course, as always, we want to see if it actually did the job we wanted it to do, right? So we're gonna do a dot head. Yep. And oh yeah, forgot about it. So we have to set the whatever we named a new data frame to the data frame that dropped it. Remember, if you remember from a couple of meetings ago, that's the general procedure of how we went about it, right? So yeah, now the client num column is finally dropped. Just make sure whenever you're doing this, you have to set it. You essentially have to set it equal to what you dropped it, right? So yeah. Cool. And now the second thing we can do in this feature, in this example of feature engineering, is we can look back at that column called months on book. Now, if you recall from our data exploration, look at this long boy. Look at him. Look at this one data point, or data value, if you will, compared to the rest of the set. That's crazy. Now, you may be wondering why this is. I think Rohit explained it a little bit, but there could be a variety of reasons. You know, maybe the bank had a huge promotional offer that a lot of people signed on to 3 years ago specifically. But whatever it is, we have to do something, because this is an example of bias in our data set. Because if we have an overrepresentation of this data value, it's going to affect our accuracy of the model. So in this case, unfortunately, we try to preserve as much data as we can, but unfortunately in this case, it looks like we're going to have to drop that column. So I will give you another 30 seconds or so to drop the months on book column. All right, I think that's enough time. Anyone want to shout it out? We haven't had any voice call-outs today. That'll be, if you want to narrate the code. Be a nice change. Ah, yes, of course. That's the reason. Yeah, so the reason it wasn't working with just df that drop was because we didn't do in place, right? In place equals true. If we did that, then we wouldn't need to reassign it to a variable.
Oh, it's already dropped, so it's saying that I can't find it.
You have to remember, because we literally just did that. So yeah, I'm gonna ignore that. Cool. Just keep.
Wait, Sammy, rerun the copy and then rerun this cell, and the error is gonna go.
Yeah, so like what happened there, so I guess you guys should use different variables each time so that your original data doesn't get affected. You have you have a copy of the data each time you execute something.
That's the whole methodology of why we're trying to save it into different variables.
Yeah, that's like the checkpoint, and then you can, if you made a mistake, you can go back till your last saved. You respawn.
So does anyone want to type down the chat what they had for drop of months? Okay, as soon as I said it, someone came up with it. Perfect. Okay, and then as always, we want to check if we actually did it. The head function, and then we run this boy, and then yep, we got rid of that. Well, let me show you we got rid of it. Months on book is here. Months on book is not here. Perfection. Now, the third thing we do is a bit more interesting than just dropping the columns. So, as our good man Rohit pointed out, the total transaction amount and total transition count are they are useful values. However, there is some sort of a problem with just using columns as they are right now. Now, what is that problem, you ask? Well, let's take an example, right? Let's say we have 2 bank customers, right? Both of their total transaction amounts, let's say in a year, are $1,000. I mean, Okay, fine. Let's say $10,000, right? And you would think that these customers have pretty similar profiles, so the machine would also think the same, right? But the problem lies in the fact that their total transaction counts could differ, right? So one of the customers could have only two transactions where they spent like, $5,000, each time. Or you could have another person who spent, $1,000 in 10 transactions, more of a regular flow of transactions. And you can infer a lot of different stuff like that. For example, you could say someone with only, two big transactions, less committed. It's more, you're using that card more for a rare occasion, So we can convert both of these columns into one more useful column, right? And Rohit wants to add something.
Yeah, I want to ask you guys, do you think, what do you think? This is just for discussion. We have no real way to prove it, but what do you think could be an effect of two transactions of high amounts each time versus multiple transactions of a tiny amount? What do you think that could be on whether someone leaves, the effect of that? Any takers? If I came in I did the 5,000 and 5,000 two transactions at once instead of multiple, what would that? Okay, most likely they're using the card only for a specific purpose. So would that make them more likely to stay or less likely to stay? Less likely. All right. That could be, very service level account. It's like creating a second social just for memes or something. So paying for student loans in the former case and got bankrupt. What was the former case? I forgot.
Was that the one with the more transactions? I think so. Yeah, okay, yeah.
That could be one. One that I can think of is if someone comes in with a high number, a high transaction amount, but with less transactions, I would probably categorize them as like, if they have a high total amount as well. They could be a high net worth family or something. And high net worth customers generally tend to be less trusting of banks. But when they go in, they deposit large amounts at a time because they have that faith in that particular bank. And investment management firms and stuff, they play to this. They build that loyalty and trust with their high net worth customers. Are they committing credit card fraud? Now that's a completely different and very interesting question. The data set would need to look slightly different for us to analyze that, but credit card fraud is a great problem to solve.
Yeah, we brought that up in our conversation today, actually, me and Rohit, when we were going over this. So that's a great observation. So with that out of the way, what do you think we can do in code? I'll give you a hint. We have to combine these two columns into something that's more useful. So just think about that I'll give you 45 seconds this time. Good. Right track. Yeah, I'm seeing you guys' messages in the chat. You guys are on the right track. So what you're saying is I'm seeing average and I'm seeing ratio. So think about the formulas for those, what mathematical operator is involved in that. Yeah. Correct. And why don't you try to implement that in your code? I'll give you another 15 seconds. All right, I think that's enough time. Anyone want to?
That was like 5 seconds.
Okay, fine. I mean, if anyone has it, I'm more than glad to take it. Even if it's just like the high level of what you have, like if you don't have the exact code, you can just tell me what you would want to do.
We got the high level answer in there. Daniel.
Oh yeah, that's true. That's true. So do you just want me to go ahead and code it?
Yeah, I think we can wait for someone to put their answer in the chat. We have time. Because the model part isn't so intense.
So man, you're on D. That is. Oh, I'm so sorry. I did not mean to laugh. I laughed because that is pretty much exactly what I was going for. Sorry, Tyler. Oh my God, goodness, I'm a mess today. Yeah, Tyler. I'm so sorry. I did not mean to. That was not like a sarcastic laugh. I was just like, that's literally right on the money. That's great. Okay, then I'll just go ahead and code it. And in fact, since you're so kind to give it to me, why not?
Watch out. Yeah, just change the DF name in there.
Correct. Remember, guys, if anyone laughs at you for asking a question or making a suggestion, best you be heading on your way. That's not a great way to communicate or teach. Okay.
But yeah, check the caps in amount per transaction. If you want to match it.
Sorry, what did you say?
The capital amount per transaction.
Like that. Okay. See, that was a genuine laugh.
I'm very picky about that kind of stuff. Sorry.
Okay. So yeah, we have successfully made our new column, amount per transaction, which you guys very sharply made out. You know, I really like the processing. Like, I really want to get your, gears turning. Like, how can we combine these? You know, we have a total and we have a count, and you related that to the mean, the average, and that's pretty much right on the money. We have our average amount per transaction, if you will, right? So we have the ratio. That's good stuff. Good job, guys. Now, I have to add a new code block here. Now what we have to do is that we can pretty much discard these now, right? Since we've combined them into our useful column, we can just discard these. So I'll give you another 30 seconds. I'll give you 30 seconds for dropping these two columns because we've done it a lot. And then we'll check it back in.
We have an answer in the chat.
All right, Daniel, let's see. All right, let's see if your hypothesis works. Well, not hypothesis, but you get what I mean. As always. And you, sir, were correct. Now I'm gonna do. Good job, guys. And you guys are now basic feature engineers. Congratulations. Give yourselves a pat on the back. I mean, yeah, that's great. Yeah, so I just want to make this note here. So just like with data exploration, real life feature engineering is a far more intensive and complex process than what we just did here, right? This is really a small sampling of it, right? There are various techniques, and there's even, we brought up last semester that there is this program by Google, AutoML, that, correct me if I'm wrong, Rohit, but it does the feature engineering, correct? It's a machine.
I don't believe it does any feature
Oh,
engineering.
it does
It
the,
simply does the model optimization.
right. That's in the model stuff. My bad. Yeah. Model AutoML is for the model, which is what Rohit is going to show us next, right? But do you know of any auto feature engineering programs?
Not to my knowledge. That's more of something that humans would want to figure out upon conducting that analysis. But
That's true. So yeah, great job, guys. Great job.
All right.
So do you want to take it from here, Rohit?
yes, please. All right. Oh, whoops. This thing didn't update with your modifications.
Oh, that's unfortunate.
Let's hope it did. If not, I can just put them in.
Pretty sure it would have. Oh, well, it didn't? I mean,
Okay, that's
you can
fine.
technically.
Yeah.
Oh yeah, I guess you don't need. Do you need to run it? Oh yeah, you do have to run it.
Drop Monday. I would totally drop Monday. Right out of the calendar.
Hell yeah. But then Tuesday would just become a new Monday.
Ooh, Annie put a link in the chat from Google uses AI to make code. Definitely.
Dude, I feel like they make everything nowadays, don't they? Damn. That's really cool.
Sorry for
Yeah, I've heard of those auto code generators. I read a couple articles where they're like talking about the implications of that for future coding jobs. And kind of the conclusion was that we're nowhere near the amount of intelligence for them to replace, software engineers and stuff. So we're safe for at least now. We're safe. Fingers crossed.
Yeah, well, folks are coming for you, Sammy.
The machines, my own. It's so ironic. It's dramatic irony. That's what it is. Yeah, I hope we're safe, or just become a manager, dude. Safeguard your career. That's what half of people do, anyways. Or become a teacher. You can't really replace that. Well, nah, I think it's a long time until we replace teachers with robots.
I mean, yeah.
No, don't start.
Okay.
I don't believe it.
Okay. So the last part is going to be really abstract. Okay, I'm going to walk you through the steps while this executes. I'm not sure why it's taking so long. Maybe it's because Sammy and I are modifying the same notebook there. Okay, but essentially what happened here? Where is it stuck? Oh, I need to upload.
You need to re-upload.
Yeah. Oops. That makes a lot of sense.
What's the first thing you guys want to do when COVID's all over? I know I just want to meet my band and stuff. It's been a long time since we played.
Definitely.
There are some people there's a record label at UMD, actually. It's called Terrapin Record Label. It's not, I don't think it's official or anything. It's more like an informal thing, but they were talking about how like some bands are trying to get some shows over the summer. So, oh hell yeah, dude.
What?
Well, I would hope so. I really hope so that we can.
I'm just
host in the person. That would be great.
Yeah, honestly, in person it's different.
Dude, I still haven't learned how to drive. This is embarrassing. I'm 20 years old. I don't know how to drive a car. I was about to learn in summer 2020, but then COVID hit. So I'm waiting. I'm really waiting. Yeah, honestly speaking, I've heard that we still have to wear masks after the whole vaccine thing. But like,
what is happening? Oh no, it's failing.
it's okay. We can still walking through stuff that's
No. Sorry guys. Not sure what's going on. Why is it saying none type object is not subscriptable?
You ran everything?
Yeah.
Because none type seems like you didn't run something, but that wouldn't make sense because you ran everything. That comforts me, Israel. Yeah. Yeah. Honestly, the whole mask situation, I don't mind it. Even if we have to wear it until like the end of this fall 2021, I'm fine with it. It's just like meeting people, you know. It doesn't even have to be big groups of people. It can just be like, small maybe with 1 to 4 people max, This is all after we get the vaccines. No, don't go outside and don't keep on social distancing, guys. This is a BigTh AI sponsored message. Please. We already had to sequester 1 week.
I don't understand what's going on. Okay. Hopefully you guys will be able to do it. I'm gonna figure out what went wrong here, but I don't know. Should I just?
You can just go to runtime and like restart the runtime and run all once. Like I guess.
Right.
Do you want me to
do it? I'll do it.
Yeah.
Factory reset runtime. Sorry guys, this happens. Factory reset runtime. Okay.
And just go to the top and select one cell and select run all after that, I guess. Something like that. In runtime.
Wait, in place is equal to. Is that it? Let me do it without that. Sorry if we go like 1 or 2 minutes over today. Apologies for that. But the model is not that hard to understand. Just want to run it for you guys.
In-person meetings would be great. I want to get the lecture room in Arab. That'll be amazing. I know ACM hosts their meetings in that.
What's ACM?
Association for Computing and
Machinery, something like that.
Yeah, they host their meetings in that room. So why not? I mean, we're a student organization too.
Oh, is that the Fauzi room?
Yes. And Nelson room. 132.
Yeah, we haven't had an in-person meeting yet.
We started at fall 2020, which is such a cursed semester. Oh my goodness. I hated that semester so much.
Finally! Oh my god! Okay. All right, it worked. All right, now let's get rolling. Now in the model, what we're trying to do is get it to map a bunch of features to a label. And it's basically learning to learn from those features in the training data and then map it in the test data. You're going to see what exactly that means, but that's basically what we talked about 2 weeks ago. The YouTube video and everything is up. But all right, sorry to run over time, Israel, but yeah, you have the notebook and everything. Take care. Whoever needs to go can dip. But yeah, so we have the set of labels, which is Y, and we're also going to separate the features out from the label in the data frame. And that's basically what these 2 lines of code did. We just selected everything except the label, and that's going to be the X, which is the feature set. And then we're just going to do something called scaling, which helps normalize the data into like a specific range. There's multiple ways to scale it. This is just going to scale it based on minimum and maximum values in each column, but you can figure out more about that on this with this link. We have the chain test split method from sklearn monolith. That is going to divide up the data into a training set and a testing set. So we're doing two splits really. One is the feature and the label split, which is what this was. And the other is the training and testing split. So you're gonna get 4 chunks. You're gonna get X-train, X-test, Y-train, and Y-test. Basically, the training set will be this plus this, right? X-train plus Y-train. Test will be X-test and Y-test. I'm sorry if I'm going too fast, but I'm happy to stick around, talk about it afterwards. All right, so we're gonna import the stock logistic regression model. Like we said, this is an abstract implementation. We'll work up to a manual one if people want to do that. But this is just gonna import the stock settings of the logistic regression model from the sklearn library. We're gonna train it on the training data, which is X-train and Y-train. And then we're going to ask it to predict on the test data. And its accuracy was 87%. It's not the best thing in the world, but it's not. All right, take care, Rishi. Thanks for coming. Yeah. The real dipstick in a model is going to be the confusion matrix. And we're going to talk more about that. But for now, just follow this legend. And you're going to see like the distribution of the test data points and what the model predicted versus what the actual answer was. Did that customer leave, and did the model guess them to leave? That's what we're testing with the accuracy metrics that come from here. But yeah, we're done. 6:31. If anyone wants to ask stuff and go into more depth, I'm happy to stick around. I can stop the recording.